Good morning, everyone. Thanks to the Arch organization for the opportunity to present our industrial cultivation solution for spirulina and other microalgae. Do you remember the movie The Martian? In the movie, to survive, the protagonist ends up growing potatoes in a small greenhouse in Mars. I can assure you that it won't be potatoes that we will be growing on Mars. There is only one food approved by the European Space Agency and NASA for long-duration space missions, and it's not potatoes. But seriously, have you ever wondered how we will grow food on Mars in the near future to produce food in a hostile environment? Today on the Earth, climate change, water crisis, and the loss of fertile soil threaten our crops and endanger humanity's food security. What will be the food of the future? In 1974, the United Nations answered this question by naming spirulina the food of the future for its potential to feed humanity. The mission of space farmers is to make that statement a reality by using sustainable, efficient, and profitable microalgae cultivation systems. Can you imagine a crop that doubles its volume every 48 hours? A crop from which you can obtain 50 harvests per year or harvest every day? A crop where 100% of the production is food, with no waste? A crop that doesn't require fertile land or water intended for human consumption or agriculture? Don't imagine it, Space Farmers is making it a reality, and someday our systems will be used on Mars to grow spirulina. Spirulina is one of the most efficient photosynthetic organisms on the planet, transforming CO2 from the atmosphere and water through sunlight into oxygen and biomass rich in proteins, carbohydrates, saturated fats, vitamins, essential amino acids, and antioxidants. Because of its nutritional profile, spirulina is a superfood. According to NASAE, 1 gram of spirulina is equivalent to the nutrients of 1 kilogram of varied and balanced fruits and vegetables. Spirulina is rich in short-chain proteins that are easily digestible, up to 70%, more than double that of soy, lean beef, or fish, to name a few examples. Moreover, less than 170 liters of water are needed to produce 1 kilogram of spirulina, 12 times less water than soy, 90 times less than meat, or 268 times less water than fish. For all these reasons, spirulina will be an essential crop to achieve sustainable development goals and to achieve food empowerment worldwide. Currently, 90% of the spirulina consumed in Europe is dehydrated product imported from China and Southeast Asia with traceability and food safety issues, and with a huge carbon footprint in both production and transportation. Europe will be one of the markets with the most potential in the coming years. The consumption of healthy and vegan food is an unstoppable trend among European citizens. European spirulina production in 2020 barely reached 144 tons through 222 companies with an average production of 0.6 ton year, with a clear predominance of small artisanal producers over large biotechnology companies as well. To address this situation, Space Farmers has optimized spirulina cultivation in Europe by developing an industrial microalgae cultivation system that uses hybrid photobioreactors, which triple the average productivity of artisanal systems and produce food-grade biomass throughout the year. Space Farmers has developed its own cultivation technology over 5 years of applied R&D at the Scientific Park of the Alicante University. The low investment, operation, and maintenance costs of our kilometer zero cultivation plants enable us to produce fresh spirulina every day, ready to be used as raw material in food and beverages, animal feed, biofertilizers, pharmacy, and cosmetic products. Due to its ability to capture CO2 and remediate water, spirulina cultivation is a natural and effective solution to combat climate change. 2 kilograms of CO2 are removed from the atmosphere for every kilogram of spirulina. 1 hectare of spirulina cultivation using our systems annually captures CO2 equivalent to a forest of 3,500 trees and can purify up to 36,000 cubic meters of water for agricultural use per year. As a local product, emissions of CO2 during transportation and distribution are minimized. Fresh spirulina retains all its nutrients intact by being harvested daily to maintain its maximum freshness and quality, with a mild and pleasant taste that everyone enjoys. It can be consumed directly or mixed with other foods and beverages like smoothies, cheeses, ice creams, pastas, sauces, salads, stews, pastries, oils, beers, baked goods, and more. Due to its format, it is easy to use and can be cooked or fermented. It does not need to be rehydrated for use, and its texture allows for easy mixing and dissolution in foods and beverages. Competing on price is also important. 1 kilogram of freshly harvested spirulina from our facilities costs the same as 1 kilogram of dry spirulina imported from Asia. Fresh spirulina can be easily and sustainably cultivated throughout Europe, creating green jobs and wealth in municipalities where our intensive plant cultivation is ideal due to the southern European region's ideal light and mild temperature conditions. This circular economy engine is especially suitable for rural areas with depopulation and abandoned crops due to low profitability. We hope you found this exciting blue economy and food empowerment project interesting, and we'll see you on Mars. Sorry, I mean at the Arch in Saint Nazaire.